Binary molecular compounds. Binary again means what? Two. So two elements in here. You can have multiple atoms of the same element, but you're only going to have two different elements here. We're not going to deal with ternary in this because ternary implies what is present within the compound. Polyatomic, right? So polyatomics are called polyatomic ions, which mean they have a charge. In molecular compounds, do we have ionic bonding taking place? No, because molecular implies what? Covalent. So there will be no ions in here. Now, we will deal with some molecular compounds, folks, later in the year that may have and will have more than two different nonmetals. Okay, those will be organic functional groups. We will have a whole unit dealing with organic. I wasn't sure if I wanted to do it now or later. We're going to do it later. Okay, we're going to get into it later, right before our Regents exam. One of the last units that we will discuss. So here are the prefixes. 1 is mono, 2 is di, 3 is tri, 4 is tetra, like Tetris. We've had that conversation about Tetris in here, right? Every shape has 4 blocks to it. 5 is penta, 6 is hexa, 7 is hepta, 8 is octa, 9 is nona, and 10 is deca. You need to know these. How many of you know pretty much all of them, except maybe hepta? Is that probably one you probably haven't heard before? Or nona? Nona, nana. Everything else you've probably seen, right? Hepta is typically the big one, so maybe you want to star it or circle it, just so you know that one, that it is 7. And then nana, which really the way that I remember 9 is it's the only one that starts with N, like the number 9 starts with N. Whatever works for you. So basically, when we talk about binary molecular compounds, guys, the less electronegative atom always comes first. All right, the less electron. Think about what we've already talked about. Which element always comes first in ionic compounds? The cation. Folks, if you were to look at the values, the cation has the least electronegative one. Always. The cation always is the lesser of the two. So typically speaking, from our periodic trends, the general ones, the further to the left you are, that element will come first in the compound. Now again, if you were ever asked which one is less electronegative, where would you look for that specific information to compare? Where specifically in the reference tables? Table S. Thank you, Maddie. You guys used it in the last unit. We've been dealing with it. So you can always look that up. You only get a prefix if there's more than one atom present. Now we're talking about the first atom here. Okay, the first one only gets a prefix if there's more than one. So mono will never be used with the first element. Make yourself a note off to the side. Mono is never used with the first element in your compound. Mono will only be with the second element. It'll only ever be with the second element. The second element always gets a prefix, and notice the ending is "ide." That's similar to what we've been doing all along. So really, it's binary compounds. When we have binary, they will always end in "ide." How we know if it's ionic or covalent will be, if there's prefixes, it's a covalent or molecular compound. If there's no prefixes, it's ionic. So you can ask yourself first thing, how will I name this compound? When we mix everything together, it's up to you to identify what type you have. If you see a metal, you know you're not using prefixes. If you don't see metals, all right, and you don't see ammonia, it's going to be prefixes. The O or the A is dropped on the prefix if the element name begins with vowels. So like for oxygen, it's monoxide, not monooxide. Or it's not pentaoxide, it's pentoxide. That'll be something you guys will learn as we do more practice. So for right now, today, if you are putting that in there, I'm not going to count it wrong. You'll get that flow the more we do. Okay? Oxygen, you've probably seen and named stuff without even realizing it. Like, what's one compound that you guys know the name of and the formula that you've been dealing with probably since you were kids? Exactly, carbon dioxide. Okay? So, keep that in mind. It'll practice. We'll get used to it. So, let's take a look here at the first one. We have AS2O5. So, will I use a prefix with my first element here? Why? You're shaking your head yes, Jill. Why? Because there's two, right? We don't use a prefix when there's how many? 1. But any other number, we're going to use the prefix. So what's my prefix going to be for the first one? Di, and then what's the element? AS is? Arsenic. So diarsenic is what this would be. It's only if the prefix ends in A or O. So di is an I, so it's diarsenic. Notice, guys, did we change the ending of that first one? No, the first element's name stays intact. Diarsenic, and then what's our prefix going to be for the 5? Pent, and it's going to be pentoxide. Diarsenic pentoxide. Pretty easy, right? I want you guys to try the next 4 on your own. There are the answers to those 5. Naming acids. Basically, guys, a good rule of thumb is if it starts with H, it's going to be an acid. Except for water, you guys should be able to recognize H2O. Some water can be acidic. We'll take a look at that when we do our acids and bases later on this school year. For your quiz on Thursday, remember it's going to be mixed naming. What I mean by mixed naming, it's ionic and covalent. So we're going to spend the rest of today and then all day tomorrow and the first period on Thursday practicing, answering any questions you may have, and then you guys will take the quiz in the middle to the end of the second period on Thursday. But these are the 6 that you need to have memorized. They're the 6 common ones. But we're also going to learn how to name other acids that we may not see. So these ones, and again, the best way. I do have your quizzes graded already from last period. You're not going to get them back today because I still have another class to take those. Tomorrow you get them back. Folks, I can tell who actually went through and practiced. If you sit there and write out polyatomics, if you sit there and write out the acids over and over, the formulas, and then the names, you're going to get it within probably 10 minutes of writing it out. If you write it out 5 times each, you're going to know what they are. Take the 10 or 15 minutes to do that. Yeah, it's a pain to write something out, but you're going to remember it that way. But anyway, here's our order for how we name acids. All right? So we name them like an ionic compound. So you would start there. So we're going to do the first one here. This is not in your notes. You're going to add these steps to your notes. Over there to the right-hand side where you've got some blank space on, what page is this? Page 6. Okay, write these steps down for naming acids. Step 1, name it like an ionic compound. Step 2, drop hydrogen. Step 3, 8 from a polyatomic, because you're going to have a polyatomic in there with the acids. 8 becomes ic, and then acid after it. Ite becomes us, and then acid after it as well. So our list here is for ternary compounds. Binary we'll come back to in just a second. So let's take a look. H2SO3. So you've got a polyatomic. First thing I want to point out, guys, what is SO3? Sulfite. So when you look at sulfite, it's not one you had to have memorized. Its charge is a 2-. What makes it an acid? Look at the charge, guys. It's balanced out with hydrogens. We had a 2- charge. Hydrogen comes in. We have 2 of them to balance that out. That's one unique property of acids. Okay, so if you know or you can figure out what polyatomic you have, if it is ternary, to write the formula, take that and just add hydrogens to balance out the charge. So here we go. We're going to name this like an ionic compound. How would we name this if it was an ionic compound? Hydrogen sulfite. All right, pretty basic. Actually, it's acidic. Little acid-based joke there. I like it. Hydrogen sulfite. So we named it like an ionic compound. Now we're going to get rid of hydrogen. So I'm going to cross that out. So now we're looking for the ending. 8 or ite. Which one do we have here? Ite. So ite becomes us. Now how this is going to be, it's not sulfus acid. It's sulfurous acid. Okay? Sulfurous acid. Okay? And again, that's just one of those things to add that little extra R that's in there from sulfur. Sulfurous acid is what it would be. Whereas H2SO4, if we were to name that hydrogen sulfate, okay, get rid of the hydrogen, 8 becomes ic, it's sulfuric acid. So really, much like ite and 8, guys, we're talking about the oxygens. When it comes to acids, excuse me, the formula, if it's got one less oxygen, it has that ending us. If it has one more oxygen, it has the ending ic. Similar to our 8 versus 8. That's why we're looking at the endings there. I want you guys to try to name HNO2. HNO2. All right, so we go by the steps. Hydrogen, nitrite. We're going to drop that hydrogen, and what's it going to become?
Nitrous acid.
Nitrous acid. Nitrous acid. Okay? So now, when it comes to other compounds, guys, you may see, we're not going to get into much detail with it now. When we start doing Regents review, if we see it, we can go back and talk about it. But the us and the ic, those names, you've heard of nitrous oxide, right? I believe that's the stuff in Fast and the Furious, if I remember correctly, right? Nitrous oxide. Same type of thing. All right, versus nitric oxide, that us and the ic part, they have different parts than just acid or different uses. That's just kind of a naming. Again, it goes back to what? How many what you have? Oxygens. It tells you, gives you an idea of how many oxygens you have.
Is it nitric acid and
Yeah, nitric acid is in different stuff, like different foods. Phosphoric acid is in soda, and so is carbonic acid. Like Coca-Cola, if you took a bottle of Coke and you poured it in there, you can actually clean, your car battery with Coca-Cola and rust and things that can help with that. And yet we put it in our bodies, but that's, neither here nor there. So let's talk very quickly, guys, about binary acids. Super, super easy. Name it like it's an ionic compound. So we're going to name like an ionic compound. This is not in your notes as well. All right. So, for example, if I just said, let me think, H2S. Okay, that's our example, one that you didn't have to have memorized. H2S. So, name like an ionic compound. How would we name this? Hydrogen sulfide. Okay, that's step one. Step two is that we're going to make it hydro. So we're going to drop off the gen part of it. And then we're going to change the ending to ic, and then just acid after it. So what would this become? Hydrosulfuric. Hydrosulfuric acid. So that's the difference here. Even though it's similar to ionic compound, guys, when you have an acid, what word is always there in the name?
acid?
Acid, okay? It's letting you know that you have an acid. If it's not there, you have another compound where they're using the ic or the ate or the us or whatever with naming it. But if that acid is there, you know, beyond a shadow of a doubt, that it's an acid, okay? The ones that I asked you to memorize, those common ones, you're probably going to be good for the most part of the year knowing those ones. This is something we will talk about. We'll practice some more. We won't probably use it a ton until we come back to review toward the end of the year. But this is how it is. This is the kind of the way that we go with it. So let's go through into your notes. You'll want 3 different colors. So grab a highlighters or colored pencils quick.